So in order to solve this separable differential equation that we need to interpret a sentence, because they won't always just say dy dx equals blah. Sometimes they'll give you a sentence and you have to interpret into math symbols. So the sentence, the derivative of y with respect to say time t is proportional to the function y. And even if they don't do a free response question with this, more than likely they would have a multiple choice question with this, and they'd probably give it to you in sentence form and not in equation format. So we have to go through and interpret this. So we've got to come up with the math symbols that go with these words. What's one word that is pretty easy to identify as our math symbol, even if it's not in order? Can you say function? Okay, and what would we write for the function y? Y. Okay. For the function y, we would write the letter y. What else? What's another word that could tell us a math symbol? Proportional. Now this one's kind of a tricky one. So we said function y is the letter y. What do we mean by proportional?
Equal.
That would be if they were equivalent or congruent. Proportional is not necessarily equal.
Change at the same rate.
They change at the same rate. So if you think back to geometry, what I always do with my geometry kids is I say we're going to make a doll. We're going to make an Evelyn doll. And when we make our Evelyn doll, we want to make sure she doesn't look like a T-Rex with short stiffened legs. She doesn't look like a gorilla with long hanging arms. So how would we do that? How would we make sure it comes out with the right proportions?
Send it to the Swiss.
Okay. We'd measure her and then divide everything by the same number. So let's say specifically though, maybe I specifically want her doll to be 7 inches tall. How would we find that number specifically?
You take her height and then solve for what it is.
Exactly. So proportional involves multiplication and division. Making something bigger by multiplying it and enlarging it, or making something smaller by dividing it. So when they say proportional, they're talking specifically about multiplication. If they say the word inversely proportional, so proportional means multiply, proportional, times by k. K is that constant that we didn't find. If I said specifically I want it 7 inches, then I would need a specific constant k to figure out what would I have to divide all the rest of Evelyn's measurements by to make a proportional doll. So k is just a constant, and inversely proportional, is either saying times by 1 over k or divide by k. Most often they write it as times by 1 over k, but really that's the same thing. Okay, so we talked about proportional, and now we know proportional is times by k. What else? There's some other math words. Derivative. Okay. So how can I write derivative of y with respect to time? dy divided by dt. So derivative is going to be dy dt. And then there's actually one more very important word in here.
Time.
Nope, because that gave us our dt.
Respect.
Is to.
Is.
Oh.
It's such a small, deceiving word. It's actually pretty darn important. What does is mean mathematically? Equals. So now I want you to take all those symbols and put them in the correct order for your math equation that we got from this sentence.
Oh, wait. It literally just.
You don't want that yet. So, what I saw everyone have, dy dt equals y times, okay. This is a separation of variables problem. So, because this is a separation of variables problem, and we practiced separation of variables, I want you guys to try it first, keeping in mind that k is a constant, not a variable, and we do normally leave it on the same side as x. So when you integrate k, you're going to treat it as a constant, not a variable. So it should not be 1/2 k squared, because k is a constant. Okay, so I'm going to give you a few minutes to try and find what y equals by using separation of variables. Now, I guess I should say we usually leave k on the same side as t since we're using t's right now. This will be applicable over time, so we usually use t's. Okay, so we get the y over, ignore that, sorry. Get the y over to the other side, we got 1 over y, dy equals k dt. We integrate, we get ln of y, ln of absolute value y, equals kt plus c. And then we do need to isolate y, just like we've been practicing. How do we isolate y?
Put the
E. So we'd E both sides. We would get y. Now why can I drop the absolute value bars?
because when you take the e of something, it makes it a positive. So
When you do e to whatever, this will always be positive.
it's like the same thing.
No matter what you put in for that exponent. Negative exponents flip it, it doesn't change the sign. So we are always positive, which means I do not need to worry about absolute value anymore. And then the tricky part is something we practiced yesterday. What can I do when I have a plus sign?
Oh, I know this. You take them and multiply them.
Split them up and multiply them. So you get y equals kt times e to the c. And what do we know about a constant raised to a constant?
It's still a constant.
It's still a constant. So this is really, I guess maybe we should have said C1 since this is now changing to C. Look familiar? Hopefully you've seen this formula before. What do we use this kind of formula for?
Confusing songs.
Besides that.
That's the derivative one. Power of
It Population.
Population.
Guessing.
Just kidding. I was so off.
What about financial stuff?
Oh.
That's probably why I didn't think of it.
Okay.
Exactly.
You can do continuous compounding of interest with this.
Oh, yeah, we definitely did this last year.
Yes, you should have seen something with this formula, but now you know where it comes from. I always kind of thought that was cool that I can now find this formula and not just know, hey, this is the formula I use. We can actually get where that comes from. So we need to know what all of these mean. I had not had a chance to erase from last year, but Y is your final value. C is your present value. K is the percentage that it's changing by. And T is time. Oh, we could also use this for like radioactive decay.
And I didn't get it on the test.
So let's say I invest $5,000 and I get an interest rate of 3%.
Holy cow, that's a good interest rate.
Not if you're in the stock market, but yes, if you're going to a bank. And like it's just your savings account.
Savings account is typically 0.01%. 0.1%.
I swear mine's at like 2%, but maybe I'm thinking of my CD.
Yeah, it's probably your CD.
So we would put the amount we're investing, 5,000 here, where C is. We put the interest rate where K is. Sometimes they do RT instead of KT, but almost exclusively in calculus we do K. And then if I wanted to see, well, how much money will I have after 2 years, then I could plug in T. T is time. Most of the time it will be in years, but it doesn't have to be. If they tell you in days, then we use days. If they tell you months, we use months. If they do tell you years and then they say, how much money will you have after half a year, what would we use for time? 0.5. So you do have to go with whatever time unit they have given you in the problem. We could also do growth. They do, I remember my brother did a fruit fly experiment in high school. So like he started with, 2 fruit flies and then had to count every day and see, predict.
Sherlock Holmes. Do you remember that? In like the movie with
Which one?
the first one? Like the movie with what's his face? Iron Man.
Yeah, Robert Downey Jr.
Yeah.
But I don't remember any fruit flies.
Well, it was just not really that important, but I just
The second one.
fuck, dude. I didn't love it.
Amazing.
Oh, and question mark?
Okay. So let's look at an example.
Okay.
Okay, so let's suppose we deposit $800 in an account, pay 6.3 annual interest, compounded continuously. How much do you have 8 years later? Now this is not a calculus problem.
So much more. I like it when it's common.
This one is just, can you use the y equals c e to the kt? First, we have to just be able to use it before we can involve some calculus. I was just going to say, this is why you should care.
Oh no, my phone was, I dropped it at a store and cracked really bad.
Oh my gosh.
And then my friend ran into it and it was destroyed. I dropped it in a hot tub at first though. So nothing right here worked. This camera was all fogged up. It was a disaster. It was on vibrate the entire time.
So what should we do to solve this problem? This one's not even a calculus problem, so tell me.
Plug it in.
This one's basically a plug it in problem. Plug in what you have. This one we don't even have to really, this one feels like it should be back in Algebra 1, but Really, we didn't see it till like pre-calculus, but it's just plug it in. So I want you guys to also solve this problem.
Oh, 0.060.
Did you get a really big number?
They were just talking about the rate. Do we plug in 6.3 as K?
No.
What do we plug in?
0.
0.063. We do have to change it to the decimal version.
That's my problem.
So we should be plugging in 800 e to the 0.063 times 8.
Well, that's a much more.
And what do we get?
$1,324.26. If you drop the 0 before the 6, you get 1, 2, 3, 5, 7, 6.
I was.
So you do have to be careful.
If you put in 6.3%, you get 6.18774 3.4.
That's a very, very large number.
Yeah.
Which, if we think about it logically, if we had $800 over 8 years, would it really get that big?
Logically, that's like more atoms than, or that's more money than atoms in a molecule.
So
Belinda, be careful.
1,300 makes sense, but the e to the 24th, that's a little too large. Okay. So we're going to talk about one more thing today. We're not going to quite finish our discussion on using this exponential function, but we're not going to have time to go past this. Okay, so what if we want to find the time it takes something to double? One of the reasons to use this information is about half-life or radioactive decay, knowing how to work when it's in general. If I just say I want to know when something doubles, what would I use for C and for Y?
It's called the rule of 72.
So if I want to know how long it takes something to double,
Just take C and double it, put it for 1 time.
okay? So Ben suggested take C and double it and put it in for Y. What do you guys think?
Yes.
Why?
Because C is present value and Y is final value.
Because C is present value and Y is final value. So what do I put for Y?
2C.
2C. I could use this in a lot of different ways. What if I said I want to know the time it takes for something to be half?
Half C.
Half C. What if I said I wanted to know how long it takes something to be 10%?
0.0.
0.10 C. Okay. And what's going to happen to our C's?
They cancel out.
They cancel out. The C's go away. We get 2 equals EKT. And I said I wanted time, so we do need to solve for time. So what do we have to do to solve for time? Lin both sides. If we had K, we could plug it in. If we don't have K, then our answer will just have a K in it. We just won't put a number there. It'll just stay as K. And then how would I get time alone? Divide by K. So time is the natural log of 2 over K. So we don't have to be in such specific terms. I don't have to give you all the numbers all the time. Sometimes maybe we'll have the constant left over. And then if they did give me a constant, I could just go straight to this and plug it in. And I wouldn't need to go through and solve the whole equation again. So, like I said, I think we're going to stop there because I don't think we have enough time to get into the next part, really. So, homework-wise, Hmm.
Give us lots of questions. We have 40 solved.
That was not really particular use in
He's trying to use reverse psychology.
Why would I do that? Who do you think I am? A psychologist?
Yeah, I think we're actually gonna not have homework today.
Really?
You're welcome.
It worked!
That's what I was thinking before he even said it.
Whatever, just kidding.
I don't feel like we've covered enough to really do the problems that are important for calculus. Like, we could do some of the pre-calc problems, but it's not gonna help us for the AP test, so why do it? So, that is why.